Someone is there. Hello. Good evening, guys. Can we start? Yeah, okay. Like yesterday, where we did we stop? Yesterday, we gone through some of the basic, like what will be VLSI and how will be the RTL design flow works, right? Can anyone abbreviate what will be the RTL design flow in the chat? Guys, you should respond. Can any one of you like abbreviate the RTL design flow? Like what does the RTL stands for? That's all. I'm not asking to explain the concept itself. Yeah, register transfer. Yeah, okay. So, like yesterday, I said that there are 7 steps, right? Like first step will be specification. First step will be specification. We need to specify what are there and what we need to do. And like second step is to write the RTL design code using Verilog. Verilog means it describes the behavior of hardware. And third step is like verification. We need to verify the code that here we are going to find the bugs in the code, internal bugs. And in synthesis, we are going to convert the RTL code into in the form of logic gates. Why logic gates? Because VLSI works in the form of logic gates. Everything inside transistor registers are connected using logic gates. So we are going to use convert the RTL code into logic gates. I can give you some example for this why logic gate because if you guys know programming language means like how the machines works, it works in the form of zeros and ones. Okay, in zeros and ones means it works in zeros and ones, right? So why zeros and ones means because these are the codes. What codes? Bits. Okay, these are the bits or called as byte codes. So every code that you guys are written in a human language, in a human readable form, okay, that are converted into this kind of zeros and ones. Okay, that code is readable by machines. So we need to convert that human readable language into machine readable form that are zeros and ones. So how to create these zeros and ones? By using logic gates. Like what will be the logic gates output? If you guys are familiar, most of you guys are from EC or electronics branch, right? Or electrical branch. So your guys will be familiar with logic gates. Okay. So there is one logic gates that is called as not logic gate, right? What it does, it converts into opposite forms. Like if you give zero to a logic gate, it converts to one. So what I'm saying is the logic gates work basis on the zeros and ones. Okay. Yesterday I said about one concept. Remember, you guys remember, right? What is transistor means? Can you, anyone guys, anyone of you like describe what is transistors in one word? What are transistors in one word in the chat? Guys, you should be fast, okay? Yeah, it is a switch. Oh yeah, yeah, yeah. Most of them are right. It is a switch, okay? In one word, you are going to describe a transistor means it is a switch. What does it does when you pass some when task is going on, it's turned on. Yeah, toggle state. Toggle state means it like for a there will be on a clock frequency, right? In electronics, there is a concept called as clock frequency. What does it does? Like the toggle state mainly works on this clock frequency. I will explain it later. For just a brief, I am saying that what is clock frequency. Clock frequency means when the frequency goes high, the toggling effect happens. Okay, and for another clock frequency, the toggling effect goes down. Okay, just on and off. Toggling means on and off. Okay, yeah, like and next stage will be static timing analysis. What does we do here? Static timing analysis means in what word need to say means like it defining a path, like which if a person traveling from a I gave three examples, right, of three persons, one from traveling from Chennai, one from Hyderabad, one from Kerala somewhere. They are traveling to Bangalore to like do some task. So in static timing analysis we need to define the timing so they can arrive at that particular place to make that task done. Okay, and in physical design means we are going to like check where the roads will be there and everything, and where on a chip how to design a chip and how to place a transistor on that and how to place an IC on that, a register, etc. Okay, sign of check means yesterday we didn't talk much about sign of checks, so today also we are going to skip because it is not that important. Okay, it's only it dependent on fabrication, like you are designing a design, right? So you need to check sign off of that fabric design or a fabricated design. Okay, next last step will be tape out. Guys, you should like tape out means I said one word, right? That if any of you find while you are designing a RTL, or if you are like you are going through RTL design, if any of you find design at an tape out, okay, if any of bug, if any of you find bug at a tape out, then it is very difficult, like it's 100 times very difficult to solve that bug rather than finding that in RTL design. Okay, make sure that you always guys clear your bugs at RTL designs. Okay, then this was the main topic we learned in yesterday class, right? Other than that we only gone through transistors and how that in history of transistors, how the transistors came to existence, how now current Apple M3 mg are going right now. We only know about that, right? So today we are going to deal with the like minimal basics of VLSI. What we are going to learn and is that digital logic refresher. Okay, do you guys have any idea about a digital logic refresher? Can you guys put in chat so I can read that, so you guys know that your guys are listening? Okay, just if you guys put one word also I can understand, oh this guys know something about a topic, so I can continue the class. And also be fast. Okay, no sir, no idea. Digital logic refresher means It's nothing but a digital logic. How do you use digital, like using NAND gates, NOR gates? That is called as digital logic refresher. Okay, I yeah, I will explain. Okay, so before guys building complex chips like CPU or GPUs, right? In VLSI, what your guys going to build? Chips, right? IC chips, processors. Okay, so before building complex chips like CPUs or GPUs, we must first understand the basic building blocks. So basic building block means, like, think CPU and GPUs are tall infrastructures, buildings, okay, and these building blocks are called as bricks, cements. What you are going to build using that, and rails, okay, and these building blocks are called as, what are these building blocks will be? Can you guess what will be that building blocks? Can you guys have any idea what will be that building blocks? Most of you, like, your if you guys are from EC or other than ECCS also, you guys will be know that, you guys will be familiar with that word, what I am going to say, like what will be that building blocks. You guys know, heard of logic gates, right? uh, yeah, so the what is that the building blocks are called as, the building blocks are called logic gates. What does logic gates do? It defines the logic. Okay, so first we are going to discuss what is digital logic. Okay, digital logic means zeros and ones. Okay, the like, yeah, zeros and ones. Yeah, digital electronics work using only two values, that is 0 and 1. What does 0 comprise to? 0 is comprised to off, 1 comprised to on. So they are nothing but the switch. Okay, consider digital logic as a room switch. In every corner of the building we will have switch. So what does this switch do? If you turned on the switch on on state, the light will be starting low, and that will be stages 1. And if you turned off the switch means it goes to 0, off state. Yeah, that's what I'm saying. Digital logic means it always deals with zeros and ones. So most of the digital electronics works on zeros and one. Okay, so next time saying, like, computer understand only these two states. What I'm saying is computer machines, everything will be works on only these two states. So to convert, I mentioned in RTL design flow, I mentioned one step, right? Mentioned this step, right? Which step? Like synthesis. This is where that code, you have written some code in English language, mathematics, algebra, using algebra you will write some code that you guys understand, like conditions, everything. But what does this machine understand? It always goes through zeros and ones. Okay, byte code, it always understands the byte code. Okay, that we can't read. Okay, and so computers understands only these two states. So all images, videos, games, apps, everything becomes combination of zeros and ones. Okay, so I said here images, right? Images, how images are built? Images are built using pixels. Guys, wait 1 minute. You're in the school, right? What's your technology? Share. sorry for the interference. Okay, now we can start. Like we left out that computers only understands two states that are zeros and ones, right? So I am explaining about images. Images are built using pixels. What that pixels range from? Pixels range from 0 to 255. So like for a building image you need pixels size, like pixel 0, pixel 255. They defines the color of that image. So like that, for to computers to understand what's going on with the code, like every English line alphabets are converted into zeros and one, so they can understand and do some task like what they are given. So what I'm trying to say is that at last, computer can't understand human language, and humans can't understand zeros and ones. Okay, and next topic is about everything about gates. You guys know about gates, right? And types of gate. Can you guys name some of the gates that you have learned so far? Yeah, NAND, NOR, NOT, and or NAND, XOR. So, you guys, any of you guys heard about universal gates? Yeah, okay, we can come later for that universal gates. Yeah, NAND, NOR, yeah, those are the universal gates. So what I'm saying is that then what are logic gates? Okay, what are logic gates? No, not I'm asking which logic gates you know. I'm just asking like one single line, like what and how you can describe the logic gates. Yeah, building blocks. Yeah, you got you got that point, right? Building blocks. So logic gates is a building blocks to build complex IC chips. Okay, but it is also defined as logic gates are the electronic device decision making. Okay, electronic decision making circuits that take inputs and generate output based on logical rules. Okay, can I repeat logic gates means? I will repeat this one. Logic gates means logic gates are electronics decision making circuits. What I am trying to say is they are electronic decision making circuits that take inputs and generate output based on logic rules. Remember these words. Logic gates means it is an electronic decision making circuits and that takes input and generates output based on logical rules. Okay, just remember this. For the time being, after some time being, I'll explain what like how that works using some of the gate as an example. Okay, uh, you guys know about some mentioned some of the logic gates, right? NAND, NOR, AND, OR, XOR, NOT. Okay, so first we need to know about line by line, like AND or like what is AND? You know about anything about AND? And okay, no answers. Okay, continue. Yeah, AND gate means the AND gate output only one. Like it outputs only one if all the inputs are one. Other than inputs like 0, double zero, 0, 1, 1, 0, it's it like it does nothing. Like output will be zero for that. But when does AND act means? when the all the input state will be 1, so that and can it perform its task. Okay, so what I'm trying to say is, you guys all know about and truth table, right? See here, there's an and gate, right? And gate, like how do you define an and gate? A dot b, like a into b. Okay, what does it does? Like, so you guys should always know the boolean expression of all the logic gates. Okay, so y is equal to a into b, it and logic gate. What does it does? Like, I will explain this truth table in a simpler way, right? Listen carefully. Okay, so what does it does? Like, consider a as a father, b as a mother, and y as a child. Okay, so in a family, when father is also not earning, mother is also not earning. Okay, father is a, mother is b, right? Both of them are not earning anything, their income is zero. Then like they can't be happy, right? If they are not earning means they can't be happy. Happy, not happy means zero, consider it as zero. Okay, and mother will be lost also, like not earning means it will, happiness will be zero. So like child, they can't provide anything to child. Okay, just like that, if any one of them is earning means, like they will be also not earning happy, because they will be middle class, right? How can a middle class people become happy with only one person earning their family? So if father earns, mother not earns means, then also they can't provide everything for that child. So if both of them are earning, okay, then they can give uh, like what their child desires, like, and they provide everything for their child. Okay, so that's how the works. Like father, to for and gate, how it work means, both of the inputs will be one, so the output becomes one. Okay, next we can go for OR gate, right? OR gate means, like, what is OR gates? The OR gates outputs one if any one input is one. What I'm trying to say is here that it defines the dominance. Okay, dominance of one input, like the which state will be on, it defines dominance of that state. It like what I'm trying to say is that if a is on, then it creates dominance over b, so the output will be 1. Okay, and if the both are like both are in on state, like a also 1, b also 1, so here both are like uh, defining their dominance. I am in on state, b is also defining, oh, I am is also on state. So here what they happens is, they will compromise with each other, and they will give result as 1. Okay, I can't also a says, hey b, I can't lose to you. And what does b says? Hey, hey, I can't lose to you. So like that, they here the compromise, they like they create compromise between themselves and create one output. So what I'm trying to say is, OR gate works when one of the input creates a dominance. Like, if they have one means, hey, I am in on state, you can't dominate me because you are in off state. So it describes like that. So what I'm trying to say is that uh, for OR gate to work, any one of them should be in on state. Okay, and let's next go for NOT gate. So NOT gate means nothing but inverter, like it inverts, that's all. Okay, what does it do? Like, if you are uh, in an off state, your input is off state means, it inverts and create on state. It reverse. NOT gate is nothing but reversing that input. Okay, so for gate, the symbol is dot. OR gate for symbol is plus. For NOT gate, either you can wait. Either you can like use like uh, a dash above the alphabet, or you can also give a simple like say a colon or something. Sorry, code or something above the alphabet. Wait, I will show you guys in the paint section. How does that? You can either mention inverter like this, symbol like this, A, or like this also. Both means inverter only. Okay, not gate. So reversing the your input. Okay, and next go for NAND gate, right? Listen carefully. NAND gate and is most important gate in your logic gates. Okay, because you guys in many in if you are going to build an IC chips, okay, many of the IC chips NAND gate is very important. Like most of them use NAND gate only. I will tell later like why only NAND gates, why we are using most of the gates will be NAND. We can use AND gate, OR gate, NOT gate also, but the most of the gate you are going to use in IC chips is NAND gate. Remember that, okay? So what is NAND gate? NAND gate is combination of and NOT gate. Okay, what is NAND gate? NAND gate means combination of NOT and. Okay, in that what happens is in NAND gate it first performs and operation. You guys know and operation. How that and operation works? If and operation 2 proceeds, both the input should be 1 or else it doesn't proceed. Like in NAND gate also, first the NAND gate logic gate, you are seeing here the gate, right? In NAND gate, it first performs and then it performs not. See here, you guys can see the truth table, right? What will be the operation of A and B for AND? If A is equal to 0, put, put that in chat, okay? If A is equal to 0, B is equal to 0. What will be the output of for AND gate? Yeah, 0, 0. But see here, what you have got output as 1, right? How did that 1 come from? Like internally, this NAND gate is first performing AND gate. So the output of A and B is 0. If A is 0, B is 0, then of course the Y will be 0 because it is combination of NAND and NOT. But here not have 1, right? So how does this 1 came to existence? Because after NAND gate, it going to perform NOT gate. So it reversing that 0 into 1. Like that also for if 0 and 1 same, 1 0 AND gate NOT gate, 1 1 AND gate output will be 1. For reversing that you will get 0. Okay, next we will go for NOR gate. Okay, NOR gate means now I will just ask you, can you guys tell me the what will be the NOR gate? NOR, NOR, NOR gate. Yeah, as the name suggests, NOR. N means not, OR means OR gate. Okay, so NOR gate means combination of OR and NOT gate. How does this work? Okay, it first performs OR operation. It first perform OR operation and then invert that output using NOT gate. So like If A is equal to 0, then B is equal to 0. In OR gate we will get 0 as the output, but here we have 1, because after applying the OR gate here, we are going to apply NOT gate. So of course the output will become a reverse of that what we are going to get from OR gate. Okay, so then final output will be 1. Here also 0 1. The OR gate, if any one of the input is 1, then it shows dominance over the other input. So of course the output will become 1. But inside the NOR gate we also have NOT gate, which is going to inverse the output from OR gate. It not inverse the output from directly from A and B. It's, it just inverse the output from OR gate. Like look, if you imagine, this is what NOR gate looks like, and if you replace this with NAND gate means AND gate means you will get, okay, you will get uh, NAND gate. Okay, here what going to happen? If A is equal to 0, A, this is B. Okay, if A is equal to 0, then B is equal to 1. B shows dominance over A, so the output of this OR gate will become 1. So here we have inverter, NOT gate. What does this do? This convert the input given to the inverter into reverse form, so that will become 0. Okay, so this how the OR gate, sorry, NOR gate works. It's a combination of OR and NOT. Okay, and next we will go for XOR gate. Okay, what does XOR gate defines as? XOR gate works when your outputs inputs are different. See here, if A, look here in a truth table, A is 0, B is 0. The both are same, so XOR gate is not activating that time. So it defining the output state as 0. Now look here in 0 1, A is 0, B is 1. Okay, so what is it telling? uh, for our inputs, what this input defining to the XOR gate, that A, sorry XOR, uh, like think myself as a, I'm going to say a sorry XOR, I'm not turned on this time. Okay, so B says, yeah, I am in on state, I we can like can perform the task like that. It will say for that XOR gate, then the process will continues. So how does this XOR gate works means, it perform tasks when any one of the input is in on state. Okay, so their input states like A and B, they should always be different. If they are in like synchronous state, like A is also B, A is also 0, B is also 0, A is also 1, B is also 1, then they don't work. Because here I said like that in a OR gate, if A and B are 1, like they can't show dominance over each other. They will just compromise and say, yeah, we will work with it together. But in XOR gate, if both of them are in on, like on or off, okay, they can't compromise with each other. Okay, so they just, yeah, you go your way, I go my way, then like that happens means no compromise means there will be no task will be done, right? So what I'm trying to say is like, this will in if you guys in final year or some things, you guys will have a final year project, right? So if you both guys ignore each other means, then the like total task performed in that project will be 0. So to perform the task, anyone should put a lot of effort. So what I'm saying that OR gate, in OR gate, one of them should work more than the other. Like there should be some difference between each other. uh, that's what XOR gate is all about. Then next go for XNOR gate. What does this XNOR gate defines? Okay, XNOR outputs one. XNOR outputs one when inputs are same. Here what is happen is, like, it is completely opposite to this uh, XNOR gate. Okay, how does completely means, they will just uh, say that, like what I said, give an example, right, on a final year project. See, this other than like XOR gate, for XOR gate, I gave one final year project example, but it is more suitable for XNOR gate. Why? Because most of the groups will be like, there will be a lot of threads inside there. Them, okay. What they usually do, you work this, I will work that. Okay, you will divide the work between you guys yourselves. Okay, so if you guys don't work, means, like, if any one of the guys will don't work means, then the project will not go, right? That will be zero. If one of the guy uh, don't work means, like A doesn't work means, then the other guys project will be part will be pending, so the output will be zero. So if both guys don't do the work means, you guys think like planning to give, like we will give to some freelancer, they will do the project. If both of them don't know how to work itself, okay, they will just go to the freelancer and make that project done, then the output will be, oh, the project is done. And if both of them are talented, okay, they can do anything. Like they can code themselves, they can convert that, like, code into some web pages, okay, some chips designs, then the task will be automatically done, right? So what I'm trying to say is that in XNOR gate, like both A and B, like both your and your friends mind should be same, then only you guys can succeed in that part, right? So the both the input should be same, then only that XOR gate works. Okay, there's another one gate. Most of them ignore this gate. Okay, this buffer gate, they're called as buffer gate. Okay, sorry, 1 minute. Sorry guys, sorry. Can we continue with buffer gate? Can you guys, any of one of you guys can state the buffer gate in the chat? Do you have heard of buffer gate? Guys, put the message in the chat, guys, so I can know that your guys are listening to the class. If you guys don't know the answer means, then say, sir, I've got no idea, sir, like that. So repeat the question. Okay. So you guys know any idea about buffer gate? What is buffer gate? Have you heard of the buffer gate regarding the anything regarding the buffer gate? Yeah, that passes the input to output without changing. Yeah. What does it generally do? The, like, what does this buffer gate generally do is that it passes the a input value to output. So internally this is doing one work. Can you guys guess what work is doing other than copying the output, input to the output? Guys, fast. If you are guys this slow means you can't learn every concept in VLSI. You guys should be quick. If I say something, you should guys chat at that time only. Okay. Do you know for what functionality this buffer gate is doing in the chat? Yeah. Okay. I will only say the buffer gate is trying to do is it doesn't make the signal weak. Okay. What does it do? So see here. Sometimes what happens in IC chip is uh, you are like connecting through transistors from different positions. Okay. So what does this buffer gate do in that position is that you are going to place that buffer gate between that like two transistors which are far away from each other. Okay. So what does this buffer gate does? One signal is coming from one transistor, so it like it need to go for another transistor, right? To perform the tasks. So this buffer gate takes that signal from that input transistor and gives that uh, same signal to the another transistors. But internally what is it doing? It not letting that signal to become weak. It converting that same signal into a strong signal, like it maintaining the strength of that signal. Okay. Just remember this. What does the buffer gate does? It doesn't let the signal to get weakened. Okay. Just note that in. Okay. Yeah, that's all about the gates. Okay. I did mention something about universal gate, right? So I will tell like how that universal gate works after some concepts. Like if you guys know about De Morgan's law means you guys can get easily what does the universal gate does. Okay. So don't worry about that. Not going to leave that point. Okay. Then I did mention like De Morgan's law, right? Before going to De Morgan's law, we need to know the difference between combinational logic and sequential logic. Okay. Do you guys have any idea about combinational logic versus sequential logic in the chat? Guys, fast. Do you guys have any idea about combinational logic versus sequential logic? If you don't know, don't worry. Just put no, sir. No, don't even call me sir. Okay. Just put no. Okay. 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 Yeah. Combinational logic depends on present inputs. Then what about sequential logic? Both present and past inputs. Yeah. Exactly. Yeah. No, so what I'm trying to say is combination logic is what she has like yeah, combination logic depends on the input only, sequential depends on the past and present. Yeah, yeah. 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 What I'm trying to say is combination like logic depends only on current input. So what the input you are carrying, right? Only that input. And one main important thing, why does it only relies on a present input? Why combinational logic only depends upon current input means it doesn't have memory. Okay. Why? Like it doesn't have memory, so it can't remember the past inputs. So okay, it will think like one work at a time. If I am carrying this work means I should carry this work till it ends. But in sequential logic, it has a memory to store something. So it relies on both past, like it can works on past and present. So for a good example, for combinational logic, I will give a real world example like calculator. You guys have used calculator, right? How does that work? If you guys give input 1 plus 2, what does it prints? 1 plus 2 is 3, right? It doesn't, and afterward you are giving 1 plus 1, then output will be 2, but it doesn't give the past and the present value. Only gives the current value, current task what is performing. But in sequential logic, if a good example means, you guys all use WhatsApp. Most of the people why I am even asking this question. Everyone will be using WhatsApp. You guys all got this class link in WhatsApp, through WhatsApp only, right? So so yeah, the good example is WhatsApp. Why WhatsApp means? Because it has memory. It can store the previous messages you have guys done. Okay. So what I am trying to say is sequential logic is very important. Why? Because why? You guys can ask why. Because the most important thing the sequential logic as other than combination logic is memory. So what I am trying to say is memory makes circuits intelligent. Okay, keep that in mind. Memory makes circuits intelligent. So that we so coming through combination logic and sequential logic, we can come pass through like flip flop. Okay, don't go through deep inside this concept flip flop and clock signal. Just like you need to keep that in mind. So oh yeah, flip flop means this. Yeah, it does this. Okay, like that. Afterwards, when going through concepts, you can learn about flip flops. Okay, for now just know that what does flip flops do. Okay, flip flop means they are the memory unit, one bit unit. Okay, one bit unit means it just only carries one time, 0 or 1. One bit memory means only one bit at a time, that will be a 0 or 1. Okay. uh, so I'm generally asking you guys, do you guys know about anything about zeros and ones? Sorry, bit and bytes, difference between bits and bytes. Guys, fast, time is learning, only 8 minutes left to end the class. Bit, okay, yeah, you know guys, right? Bit and bytes, what does, so how you represent bits, and how you compare bit and bytes within each other? Yeah, one byte is equal to 8 bits. And there is another word in like this code. There is word called nibble. Okay, nibble means 4 bits. Okay, yeah, 4 bits. 1 bits, 4 bits, and 8 bits. 1 bits means 8 bits, 4 bits means nibble, 8 bits means byte. Okay, so what I was telling of something about flip flop, right? So what does this flip flop does? It just toggle the state with the help of clock signal. Okay, it just a state, like it changes the state on the rising edge of the clock. If the clock like raises means the flip flop will change 0 to 1. And if another clock comes means it will change 1 to 0. Like how it was the general definition of how flip flop works. Okay, and the clock signal means a signal, like it considers heartbeat of the chip. Okay, every time your heart beats, the blood will be pumped, right? So that's how every time the clock signal toggles, like goes up, this flip flop change their state bits at state 0 to 1, 1 to 0. Okay, and then I'm just going to say that what the De Morgan's law in a single word. Okay, because at least we need 10 or 15 minutes to go through this concept. Exactly what does, like, to understand this concept we need 15 minutes. Okay, so I'm like, just say one line. You guys should like, this is the task I'm going to provide you guys today. Just go and search like what does De Morgan's law do, and just try to understand it. Okay, tomorrow I will going to explain. Yeah, like what does De Morgan's law do? Like, it is a law which simplifies the circuits. Okay, did you get anything? It only simplifies the circuits. In previous I did mention about something about universal gates, right? The universal gates come exist in De Morgan's law. You can like, you can grab that universal gate knowledge here. Okay, in De Morgan's law you can understand better here in De Morgan's law. That's why I didn't mention say anything about while explaining NAND gate. So guys, tomorrow we are going to discuss about De Morgan's law, like why does we use this, the main goal of, and what will be the main goal of this De Morgan's law inside VLSI, and why does this simplification matters. And also, like, other than manually you are like doing some NAND like logic gates integration, you can, what happens if you guys use NAND gate inside that, and what will be the real reasons for using NAND gate. Like I said, did mention about most of the CPUs or GPUs or ICs were built using NAND gates. You guys are going to learn why only NAND gates. Most of them are NAND gates. Not only NAND gates. Most of them will be NAND gates. Okay, and how it helps the circuits, and what will be the reason for using the NAND gates. Okay, and we are going to see about something about our first Verilog code tomorrow. Okay, and you guys just make like, don't just make a search on a EDA platform. Okay, where you guys going to learn Verilog code. Okay, yeah. If you guys have any doubt, means you can ask now regarding to this class. Yeah, guys. Okay, I will consider that you guys don't have any doubts. So okay, today we are, that's it for today's class. Okay, today was like just we learned what we learned. Like we just recalled the RTL design flow. Uh, how does it like, what are the steps inside the RTL design flow, and we went through what will be the transistor, and then we started our day with using like the gates, design logic gate reference. Okay, and we learned something about gates and NOR XOR and how does they work, and we also like learned something about difference between combination logic and sequential logic. Okay, and we gone through some of the concepts like flip flops, clock signals, right? That's it. That's it for today, guys. You guys can all leave the meeting. Tomorrow we are going to for like using the demor. What will be the De Morgan's law? Just take a reference from anywhere else. Okay, what does De Morgan's law do? Yeah, guys, thank you. Bye. doesn't even work, bro.